Hi everyone. One of the other examples for simultaneous equations I know has horrible fractional numbers and goes off the screen. So I thought I'd just do an extra example to bring out some of the issues that we have to think about when we're solving simultaneous equations. So we have a situation like this. We can label these equations if we want to. And usually we want to start by getting them in the right form. So here, one of the things that you might notice is we've got y on this side, x on this side in this equation, whereas the y and the x are both on this side in this equation. So usually we like to have it so that the x's and y's are both on one side, so we get it into a like ax plus by equals c kind of format. That's what we're after anyway. So with this first equation, I might rewrite it, and we'll call it 1 dash, why not? And I'm just going to move the y to this side by adding 2y, and I'm going to move the x, the constant to this side by subtracting 2. So I get 3x plus 2y equals negative 2. For the other equation, I might just rewrite it out in a different order so that I've got the same order and I can easily compare the two equations. So it's going to be 4x plus 3y is equal to negative 4. So this is my new simultaneous equations that I'm going to look at solving, and I'll call this one 2 dash, like this. Okay. Now, what we want to do as a first step in simultaneous equations is get two equations where the coefficients of either x or of y are the same or the negative version of each other so that they'll cancel out. Now sometimes that's been easy for the equations that we've looked at because we can just multiply one of the equations. In this case, we actually need to take a combination of both of them in order to be able to get something, because there's nothing that, looking at the first equation, there's nothing I can multiply 3 by, or not like a nice number anyway, that I can, a whole number, nothing that I can multiply 3 by in order to get 4, and there's nothing I can multiply 2 by in order to get 3. So I actually need to do something a little bit more complicated in examples like this. And it's similar to fractions, so similar to like if we're adding, say, a quarter plus a third plus a quarter, I need to get like a common denominator here. So it's a similar idea to that. So what I do is I say, alright, if I want to eliminate x, so I choose to eliminate x first, so I say I'm going to multiply this top equation by 4, and I'm going to multiply this bottom equation by 3. So I pretty much cross multiply, or similar idea to what we have with fractions with these two. Now what that will give me for my two new equations, if I multiply the top equation by 4, I'm going to get 12x plus 8y equals negative 8. Remember, I have to multiply all three terms by that in order to keep the relationship. And so this new equation, and I'm going to call it 1 double dash, this new equation is exactly the same relationship as this top equation here. So they're saying exactly the same thing, I've just multiplied everything to keep it reasonable. Multiplying the second equation by 3 gives me 12x plus 9y equals negative 12. I'll call this 2 double dash. So I've now got two equations where I have the same coefficient of x, which is exactly the reason why I chose those numbers to multiply by in the first place. So this shouldn't be surprising. Now, one thing to note, I could have multiplied this bottom equation instead by negative 3, and then I would get negative 12x, I'd get a negative 9y, and I'd get a positive 12. And the only difference that would make is in my next step. So in the next step, I'm going to subtract these two equations. If I've got 12x and negative 12x, then I'd add the two equations in order for x to cancel out. So some people prefer to work one way, some people prefer to work another. It's completely up to you. So I'm going to do it this way, and I'm going to subtract because I've got that 12x for the x and the x. So I'm going to actually be subtracting. We think of it as subtracting this whole top equation. The x's will cancel, and then I get 8y minus 9y, so I get negative y here, equals, and then I've got negative 8 minus negative 12, which is negative 8 plus 12, equals 4, and then from this I get y equals negative 4. So rearrange there. I can now substitute my y value into either of the equations, any of the equations that I have. So what's the easiest one? None of them are particularly great, but maybe let's use this top equation. So all of these equations give the relationship between x and y, so once either x or y is fixed, we can find the other value. So let's use that top equation. So I'm going to get 3x plus 2 times negative 4 has to equal negative 2. Expanding all this out, so I'll get 3x minus 8 equals negative 2. Add 8 to both sides, I get 3x equals 6, and so x equals 2. And so my solution, final solution, is x equals 2 and y equals negative 4. And I can substitute those back into my original one if I want. Okay, so all of these steps we could have done in a different way. So at this stage here, if I wanted to eliminate y, I could have instead multiplied my two equations by, if I multiply this equation by 2 and this equation by 3, then for my coefficients of y, I'll get 6y and 6y there. And so I could eliminate y that way and find out what the value of x is. And so this is part of the problem, that we can always choose different ways. It's not always clear the best way to go. But basically, if we simplify down our steps, our first step is to get our equations into the same form. So get all of our x's and y's in the same spot. So if we do that, then we can proceed to work out which value we're going to eliminate. So as a standard practice, if you don't like making this decision, you can always choose x. And the way that we can eliminate x is by multiplying either equation by the coefficient of x in the other equation. So we multiply this top equation by 4 because the coefficient of x is 4 in the other equation, and we multiply this bottom equation by 3 because our coefficient of x is 3 in the other equation. So we can always do this. And then we can subtract one equation from the other and we'll eliminate x. If we follow these steps every time, we should eliminate x. And then after that, it's just rearranging, solving y, putting it back in. And don't forget, you can always substitute these values back into your original equations to make sure that you've made no mistakes along the way. Okay, I hope that's useful. I hope you're all having a great start to trimester. Or end of trimester, who knows when you're watching this. And I'll see you soon. Bye.